NEC 250.24 requires that all ungrounded conductors of a separately derived system be grouped together and protected by a common disconnecting means. In an arrangement where the neutral conductor, which is grounded, is not grouped with the ungrounded conductors, which are the phase conductors, and is not protected by the same disconnecting means, a potential problem exists. If the neutral conductor becomes disconnected from the grounding system, it could become energized and pose an electrical hazard. In the event of a ground fault, the lack of overcurrent protection on the neutral conductor could allow excessive current to flow through the grounded conductor, potentially damaging equipment or causing a fire. To comply with NEC requirements, the neutral conductor should be grouped with the ungrounded conductors and protected by a common disconnecting means, like a fuse. One option is to install a fuse in the third pole of the fusible disconnect with the same ampacity as the other two poles. Another option is to install a circuit breaker in the third pole of the fusible disconnect with the same rating as the other two poles. A third option involves replacing the fusible disconnect with a 3-pole circuit breaker. The goal of NEC 250.24 is to ensure that all ungrounded conductors of a separately derived system are grouped and protected by a common disconnecting means. This is intended to prevent hazards associated with a disconnected or unprotected neutral conductor. Specifically, NEC 250.24 addresses the grounding electrode conductor connection location and the requirement for common disconnecting means for separately derived systems. The NEC is a comprehensive set of standards designed to ensure electrical safety. Separately derived systems refer to electrical power systems such as those supplied by transformers, generators, or solar inverters that are electrically isolated from the main power source. When dealing with separately derived systems, proper grounding and overcurrent protection are crucial for preventing electrical hazards. Ungrounded conductors, also known as phase conductors or hot wires, carry electrical current from the source to the load. The grounded conductor, commonly referred to as the neutral, provides a return path for the current and is intentionally connected to ground. The disconnecting means is a device, such as a fuse or circuit breaker, used to interrupt the flow of electrical current in a circuit. A common disconnecting means refers to a single device that simultaneously disconnects all ungrounded conductors of a circuit. Overcurrent protection is the use of fuses or circuit breakers to protect electrical circuits from excessive current, which can cause overheating, damage to equipment, and fire hazards. A ground fault is an unintentional electrical connection between an ungrounded conductor and a grounded surface. If a ground fault occurs, a large amount of current can flow through the grounding path, potentially causing damage or injury. Ampacity refers to the current carrying capacity of a conductor, typically measured in amps. The ampacity of a conductor must be sufficient to handle the maximum current that it is expected to carry. A circuit breaker is an overcurrent protection device that automatically interrupts the flow of current in a circuit when an overload or short circuit occurs. A fuse is an overcurrent protection device that contains a fusible link that melts and breaks the circuit when an overload or short circuit occurs. The rating of a circuit breaker or fuse refers to the maximum current that it can safely carry before interrupting the circuit, typically measured in amps.